Well, hi, good morning. Thank you so much for coming and spending time with me today while I work on, or at least test out, this scope. So I think it's in working condition now. Whether it's calibrated or has all its functions and all that kind of stuff, I don't know. I do have the user manual that comes with it, which is very valuable, but I have not been able to find a service manual for this particular scope. So in here, along with instructions on how to apply it to some simple electronic troubleshooting issues, mostly with televisions, color televisions and the like, there is a section in here on calibration. Not calibration in the back, but just using the front panel controls to calibrate the scope. So we're going to run through that. And also we're going to try the intermittent analyzer again, which I realize now I wasn't using correctly, of course, before. But now that the scope is working, it's worth putting a little bit of effort in finding out if the intermittent analyzer works. You could really see the value of this kind of device, this intermittent analyzer function, in a shop where someone has presented you with usually a television, and they say, I don't know, once a day the color disappears for 5 minutes, and you're supposed to try to find that problem. Well, you can't sit for 24 hours staring at some piece of test equipment waiting for the moment. And the manual mentions another effect which I've experienced quite a few times, where a piece of equipment goes into some kind of misoperating state, and you whip out your test equipment to find out what's going on during that state, and as soon as you apply one of your test probes, the state goes back to normal again. It wipes it out. So in this case, this overcomes that problem because you connect it to the circuit and leave it, and you're not making or breaking any connections while you're doing the test. You have it hooked up. The intermittent problem appears. You're not running over and trying to poke around or whatever. It would still take a long time to use this to trace down a problem, because what they're suggesting here, in the case of a television, old-style televisions have many stages in them. Where can I find a diagram here? There we are, showing all the different stages in the television. And what they're saying is, okay, hook up the scope, here, wait for an event to take place. Okay, now you know the event can be seen here. Can you see it here? Can you see it here? Okay, can you see it here? And you kind of, zero your way into what stage is causing the problems. Well, that could take a long time hopping around inside a TV set with all the other challenges that come along with that kind of work. So, okay, I closed the book here. I don't want to close it because we're going to do the calibration thing right away. Well, yes, on the back of the scope, there's a panel. You can remove the panel and you have access to a bank of terminals right back here. I won't spin the scope around. You can see them from this side, actually. Bank of terminals here. And what that is it can give you direct access to the deflection plates in the CRT. If you, for some reason, should want to bypass all the works and just put your signal right on the plates, you can do it. This also talks about particular scope leads. No doubt they were trying to sell these scope leads at the same time they're selling the scope. So it talks about using these special leads, a direct lead, a low capacity lead, and a demodulator probe. So demodulator probe, that's kind of where I got the idea in my head that you use the demodulator probe, develop a DC voltage. I'm not that familiar with demodulator probes, unfortunately, and I should be. I will be down the road. But my thinking was the scope on the intermittent analyzer is monitoring a DC level between limits. If it goes high or goes low, then this thing clicks on. But actually it's not. It's actually a AC signal, some kind of signal, usually a video signal I would imagine, but it could be any kind of signal. But you don't need to rectify it and produce a DC version of it. So I got a little misled there. Okay, let's do the calibration steps here. Calibration procedure. Here we go. Turn the unit on and adjust scale illumination to maximum brightness. Okay, let's do that. There we go. Let's see if it's stable today. Maybe it's become unstable again. Maximum. Still have one bulb burned out here I haven't replaced yet. Here it comes. Are you stable today? Well, I was cleaning these knobs and spinning them all left and right here and there, so. Okay, that's number one. Number two. Set vertical range to the vertical calibrate position. Okay, vertical range. Vertical range is here. The words for it are written, just hidden from view under here. Actually, you don't need to be so tall. Why don't you shorten up a bit? There. There we go. Set it to calibrate. Vertical calibration. Oh. Oh. Huh. Okay. Note 0 to 2 scale is lit. Well, yes. The only one that can light on this. only one with a light bulb. Set horizontal scale. Sorry, set horizontal gain to minimum. Horizontal gain to minimum. I believe that's what I just did. No, gain is this one. Oh, it just disappeared. Wait, let's just keep it on the screen here for a minute. Oh, this is the position. Okay, let's not. Minimum. That's why, because they want a line. Okay, check the focus. There's a nice sharp focus on this scope. Here we are. Adjust intensity and focus for the best appearing vertical line. I did that spontaneously. Number 6. Use the horizontal position control to position the line on the 0 to scale. Okay, so the graticule is about maybe almost a quarter of an inch in front of the glass. I guess it would actually be the inside of the CRT tube, and that's causing a parallax error of some significance here with this scope. My other scope in the background here, the graticule is right on the front of the tube, so there's very little problem there. I did drink half a cup of coffee already. So adjust the calibrate control so the line is exactly the same length as the 0 to 2 scale. Vertical position may have to be adjusted so the lowest point of the line touches. So adjust the vertical. This is the position. Vertical. Oh, that's right. It must be this calibration here. Yeah, that's it. Okay, so we're gonna try to position this. Okay. The idea here is I'm discovering if this can be done. Is the scope working? And this is one way to try to find out. Yes, it looks like it can be done. I just did it. This completes the calibration for all ranges of the vertical range switch. Wait a minute, not with this here. This is, I missed something. This is let's go over it again. Set vertical range to vertical calibrate, horizontal gain to minimum. Horizontal gain to minimum. Adjust intensity and focus. Use horizontal position. Vertical position, vertical range switch. They never mentioned the, so this has got to be, I suppose, like that. Oh my gosh. Well, the situation has changed dramatically. Wait a minute, this is vertical position. What are you mumbling about there, Jim? You just did this and then forgot what you did. Okay. So I thought this was a vertical amplification setting. Oh, here we are, position and range. Okay, doke. Okay, well, I'm going to make a few mistakes. It's the first time I've done this. Interesting statement in here. Let's see if I can find this statement. Note. I'll just read this. I've never heard this before on any scope. The trace on this oscilloscope may appear to be tilted. This tilt is the result of the magnetic field of the Earth that varies from area to area. If you find the tilt objectionable, it may be easily corrected by turning the scope tube by a small amount. To accomplish this, remove the loosen that thing, turn that thing, tighten that thing. So I've never ever heard of the idea that a scope would be affected by the Earth's magnetic field. Really, how sensitive are these things? Let me get a bit of magnetic field here. There we are. This is a very strong magnet from the back of a Sony speaker. Oh, look at that. Can you see it's moving? You can definitely see it's moving. So look how far away I am here. Wow, I'm surprised. Well, they should have mentioned that in the instructions, that if you have any strong magnets, what if you have a speaker nearby? I've never thought of these things. Well, this is kind of having a speaker nearby. Let me just grab a speaker. Easier said than done, believe it or not. Okay, I'm going to go get a speaker. I'm going to find out. Okay, I don't know if these are really big enough, but so here's a speaker. I'm going to watch the scope now. Oh yeah. And it's in a metal can too. I thought maybe this one. Oh my gosh, look at that. How far away? So I'm a foot and a half away now. Well, I'll be. That's interesting. Here's a smaller speaker. This is kind of a crummy one. Oh, let's do that too. Whoops. No, you can actually bang right into it with the speaker. That's another. Huh. Okay, never knew that. Never thought of it. Now I know. So here in my shop, I've got a couple speakers here and there. Speakers and some of the equipment. The main speakers I've got are way up high. You can't quite see it up here. One up here, and I got the other one up there. You know, have I ever showed you the wonderful sign that somebody made for me? As I'm scanning around. Look at that, that's cool, eh? Yeah, that's me. Although I don't have a red tie. I don't wear a tie when I'm in here working, but well, that's interesting. Earth's magnetic field throwing things off. So we're able to calibrate it. I don't know if there's really much else. Oh yeah, I want to check the intermittent. Okay, so I can clear the intermittent by doing that. Perfect. We'll put this off calibration. So they say during normal operation, put this in the balanced position. If this light comes on, it's because the dot, which I don't want sitting there like that. How come you're not on the move? Because I don't have the horizontal gain up, that's why. Horizontal position it kind of in the middle. And what was I saying? Oh yes, that if the display goes off the screen at the top, this light will come on. Is that really true? Can I make it go off? Not so much. I think they actually say if a portion of the signal is going off, this light may come on. Okay. Now, let's use this intermittent deal. So I need, once again, to supply a signal. This is a 5 megahertz scope, and I believe the intermittent will work up to, I'm not going to be able to find it here in this long instructions. Long instructions. I don't see it, but I think it was like 3 megahertz, but I'm not sure. Well, I'm going to put a fairly high frequency into there. We'll take it off my sweet machine here simply because it's easy to get to. Not a high voltage coming out of here. And I'll just a fixed frequency of something. And what thing? Oh, I'm just pushing all these buttons up here. Fixed frequency of 400. Let's just take it up. Okay, so this is 2500 hertz. It's still an audio frequency. We don't want it sweeping. 3200 hertz. Oh. Let me just do this in a somewhat clumsy way here. Somewhere I have BNC to BNC cables, but we'll just do this. Now, let's get this thing set roughly. So I want it a little faster. I want it a little wider. I want this a little more sensitive. Hey, the light does come on. It's just because of the way the switch was. Oh, I'm glad I didn't go and change the light bulb. That's right, I noticed that much earlier. We're on the 2-volt level here. Here we go. Anything show up? Yes, sirree. Fantastic. And this light came on already. Now it says in the manual this signal level has to be at least a quarter of the screen. So we can, whoops, wrong control. We can make it bigger this way. That's too big though. That's right off the screen. Hey, what's with that? Third in the controls. Oh, that's a troublesome thing there. It's making the lights flash. Right there. Okay. We can up the output here. That's got to be enough. So the question would be, is there some variation, some intermittent variation of this signal? So with this in the balance setting, we turn this knob until neither light is on. Okay, then we try to find the center of the no light, right about here. We flip it to operate. We now wait. Well, we can't wait here forever. I'm going to force a change in the output and we'll see what happens. So first I will drop the output down. Oh, look at that. But this didn't come on. Okay, we'll go back up. It's supposed to remember this. So only if this light comes on will it remember it. Okay, well we're going to go up bigger. Ooh, like that. I went up awfully high. But this light doesn't stay on. I thought this was supposed to remember. So you come back, you go, oh yes, the signal happened and it went high. It doesn't seem to do that. Okay, let's try again. Okay, new level. Was I supposed to put this somewhere in the screen? I don't think so. Adjust. Here we are. Operate. It's operating. We go down. Light came on right away. Didn't take much of a change. It's not going to pop this. Probably because I'm not doing this exactly right. Now we'll go up. Up. Is it a rate of change problem? Ah, you know, that's what it is. It's rate of change. So intermittents generally don't float up and down slowly. They generally jump. So let's see if we can do a jump going down. Calibrate. Let me put a going down. What do I mean going down? Less signal. So we'll give it a fat signal to start with. Put it a little more in the middle. This is a funny control. Instead of it just moving it up and down, it's like it's got a delay in it, like a capacitor charging. I don't know if that's normal. Doesn't seem normal to me. There we go. So we're balanced. We're operating. We're going down. Light comes on, but no action on the intermittent indicator. Go back up, come down quick. Come down all the way quick. I'll cut it right off here. Can't get this intermittent light to come on. But going up, slowly, way up. Up. Yeah, sudden change triggered it. So I don't know about the down thing. Maybe I'm just not doing it good enough going down. Going down. No, doesn't want to trigger it. So don't know for sure if that means there's something not operating properly or not. I mean, it's supposed to trigger on up or down. Doesn't seem to want to. Use our up or down lights. Has it out of range? Sensitivity. Yeah, I'm sure I've read this a couple times now. I don't think it really comments on anything about it behaving differently going down than up. Well, okay, but on the upside it works. And again, maybe I just don't have things set quite right. Now let's go for sweep speed. So we're going to increase the sweep speed. Start to see the individual lines here. Let me set this to calibrate. I guess this is calibrate. What is this? Fine adjust. So it's adjusting between this range of 50 kilocycles to 500. It's not really. It's not going to show this. I'm only at 3,000 hertz here. What kind of scope is this? I'm at 3,000 hertz. Am I correct on that? I am not correct on that. I am I'm at 3 megahertz. That's why. Let's take it way down to 60. Okay, so I don't see any triggering effect here. So fool around with the trigger and see what happens. Sync. It doesn't say trigger, it says sync. Internal. That looks like it's trying to trigger like any scope. Yeah. There we are. So this is 60 kilohertz, I believe. I think that's what I got going. And that's the best it can do. That's the fastest sweep there. So it has some fixed sweep settings for the television vertical and television horizontal. This will maybe a little faster here. Of course I had this thing turned. But it does trigger. And it produces a nice looking, that's a nice looking signal. I like that. Big screen, nice bright. This is positive internal. Probably this will just flip this over. Perfect. And then on the line, it's just going to run wild because the line is 60 cycles. That's my don't forget to drink coffee warner going on. Very good. What else would we want to check? Assume the calibration worked properly. I don't think anything. I think we're good. I think that's good. I think generally the scope works. Not so sure about the situation with this. Could just be I just didn't quite get it yet. Fantastic. Well, it's a talking about fantastic. It's another fantastic day outside. I'm almost embarrassed, not embarrassed, but I feel bad saying that because the weather here has really been very nice this summer. We've had lots of rain and lots of sun too. Right now we're in a cool phase. High today is only 22 degrees Celsius, of course. Maybe 23. That's cool. And sunny all day. And we're going to have a number of days like that here. Wonderful. Well, thanks a lot for watching. Tomorrow I'm off to a ham radio field day. Short short morning field day. We're going to activate a park somewhere here in Aurelia. And if you're into ham, you know what I'm talking about. That's where I'll be tomorrow morning. Okay. Wow. I gotta think about what to do with the scope. As have I mentioned, this is part of a 4-piece package of equipment intended for the repair of CB radios. So the rest of the equipment is going to start coming in here for a checkout and clean up and the like. Very good. Thanks a lot for watching, and I hope you enjoy your day. See ya.